Okay, so this is the video that we talked about even degrees. Now we're actually going to talk about odd degrees. So if you guys already got these notes, that's great. If you don't, watch my last video, and then you'll see even degrees. Now we're going to talk about odd degrees. This video is going to be strictly for odd degree polynomials only. Okay? And their characteristics. We'll talk about their end behavior and their characteristics. So this here will be odd degrees. Odd degrees, okay? Now, let's say we have this function here. This is another well-known function that everybody should know. Let's say we have this function. Let's hope that I draw it right here. Give me a second. Okay, so this here is an odd degree polynomial, polynomial function graph, of course, where the leading coefficient, let me rewrite that better. Where the leading coefficient is greater than 0. Leading coefficient is greater than 0. Okay? This means this will be positive. This leading coefficient will be positive, of course. Now, let's talk about some characteristics of this here function. Well, we'll find out what happens as x approaches positive infinity. We'll find out what happens as x approaches negative infinity. Well, if we're looking at this graph here, and of course we know that this way x will approach positive infinity, and this way x will approach negative infinity. And of course, going up this way, our p of x, our function p of x, is actually approaching positive infinity, and then we know going down here, our function p of x is approaching negative infinity. Okay? Well, let's talk about some characteristics here. If we're looking at this here graph, let's say what happens as x approaches negative infinity. Let's start with negative infinity first. What happens as x approaches that? Well, I'm looking here, x is going to negative infinity, and it looks like my p of x is approaching. What is this side of my graph doing? So basically, just to make it simple, I'm looking at this side of my graph here. Okay, I'm looking at this right here. So as x approaches negative infinity, what is p of x doing? Well, p of x is going down. So p of x is also approaching negative infinity. So we'll say p of x approaches negative infinity. Okay, or sometimes this will be called tends. You'll hear people say tends. You'll hear it tends to negative infinity. Okay, or it approaches. I say approaches. You'll hear some teachers may say tends, some students may say tends or approaches. It all means the same thing. Okay, now let's go ahead and look and see what happens as x approaches positive infinity. Positive infinity. What happens to p of x? What does p of x approach? Well, I'm actually going to be looking at this side of my graph here because I need to find out what happens as x approaches positive infinity. So I'm looking at the positive side here. So x approaches positive infinity, but this p of x is doing what? It's going up. So this p of x will also approach positive infinity here. Okay? So p of x will approach positive infinity. Now, let's talk about what the domain and what the range are of these here functions. The domain, well, the domain, of course, would be all real numbers, okay? Now, what is the range? Is the range all real numbers as well? Or do we have a limit as to how far up or how far down this polynomial function can go? Well, look at this. This function extends infinitely in this direction and then infinitely in this direction. So it goes infinitely in the p of x is equal to a negative infinity direction down here, and then p of x is approaching positive infinity. It goes infinitely that direction. So we don't really have a limit to what it could be. So we're going to say our range is all real values as well. Okay? Now, this is when coefficient is greater than 0. Let's talk about when coefficient is less than 0. Okay? When coefficient is less than 0. Okay, I know this is a terrible drawing of the function. I'm sorry I didn't even tell you what function this was. This is the function y is equal to x cubed, by the way, okay? Well, in this case, it'd be y is equal to negative x cubed. Y is equal to a negative x cubed. Because this is coefficient, which we'll call a. So let's see, this is y is equal to negative x cubed, and this is coefficient, which we'll call a is less than 0. Okay, this means it's a negative value. Okay, now let's talk about the characteristics of this function, of course. What happens as x approaches negative infinity? Well, what happens as x approaches positive infinity? What is the domain of this here function? What is the range of this here function? Okay? And will this function, and in a later video when we actually talk about graphing polynomial functions, we'll talk about why this function actually flattens out here in this space here. We'll talk about all of that, and we'll actually be using in-behavior functions to determine how these graphs of these polynomial functions will actually look, and we'll use multiplicity and our zeros to actually determine these things here. Okay? Let's go ahead and look at something here. Let's say we're dealing with, well, let me go ahead and write this out here. This would be x approaching negative infinity. I'm sorry, positive infinity. This would be x approaching. This would be x approaching a negative infinity. Now, this here would be our p of x, of course, approaching a what? Approaching a positive infinity. Let me see, approaching positive infinity, that's what p of x would do. And then down here, negative infinity is what p of x would approach in this direction here, okay? So, let's go ahead and see here. As x approaches negative infinity, so we're looking at this side of this graph here, what does p of x do? Well, it looks like p of x is approaching positive infinity. Right? It looks like p of x, that's what it's doing. As x approaches negative infinity, p of x is approaching positive infinity. So p of x approaches positive infinity. Okay? Now, as x approaches positive infinity, what happens? Well, x is approaching positive infinity. We're looking here. We're going this direction. It looks like our p of x is approaching negative infinity. So we'll say p of x approaches negative infinity. Okay? Now that we have our end behavior here done, what is the domain? Well, the domain is all real values. What is our range? The range is as well all real values because we have no restrictions to anything, okay? Like we did when we're dealing with the parabola. We had restrictions to that graph. I'll show you here in a second. We had restrictions to that graph. Why did we have restrictions? Because we had a maximum point, and then sometimes we had a minimum point here. We had a minimum point depending on what the coefficient was. We had a minimum and a maximum point. So therefore we had restrictions on how far our y values could actually extend. Okay? But in this case we don't. We don't have any restrictions on these y values. Okay? Now, just to be clear, this is the end behavior of this function here. And going back up to this example, this is the end behavior of this function. So if you're ever asked to identify the end behavior of these functions, then you know what to do. Basically use this method that we did here. And we'll do a couple of examples in the next video on end behavior of polynomial functions with even and odd degrees.